Hello Year 8, this is lesson 43 and you should be doing this lesson either on Wednesday or Thursday of this week. The title of the lesson is Measuring Your Vital Capacity and we're going to find out what that is shortly, but for now grab your pen and ruler, write the title and the date and underline them, make it lovely and neat. I've seen some of your work and it is looking beautiful. And then have a think about these starter questions. Question 1, what function do the lungs carry out? Why do we have lungs? What are their job? Question 2, how are the lungs protected? What protects the lungs? Question 3, we have got 2 lungs. What other internal organ comes in pairs? How well do you know your internal organs? And question 4, if you spread out your lungs, what would be their area? Would it A, be a trampoline, B, a tennis court, or C, an Olympic swimming pool? Have a little go, pause the video and restart when you're ready. All right, how did you do? Here are the answers. The function of the lungs is for breathing. They help to pull air into the body and push air out. They're helped by other organs as well, but that is the main function of the lungs. They are protected by the rib cage. Super important. It's got that cage of bone around your squishy lungs to make sure that they don't get damaged. Question 3, the other internal organ that you've got that comes in pairs are the kidneys. You've got 2 of them and they are near the small of your back. And number 4, if you spread out your lungs and you flatten them and you spread them all the way out, they would actually take up roughly the size of a tennis court. How amazing is that? And they're all in your chest, but if you spread them out, tennis court. So the main objective of our lesson today is to measure our vital capacity. But first of all, what does that mean? What is vital capacity? So we're thinking about the lungs. And what vital capacity is, it's the largest volume of air that can be exhaled after taking the deepest possible breath. Please write down that definition, it's important. And we're going to measure ours today. So we are going to measure how much air you can breathe out in just one breath after you take the biggest breath in that you possibly can. So you're going to do a big breath in, then you're going to slowly breathe out. And we are going to actually measure and record how much air we can breathe out in one go. Before we do that though, let's just think about vital capacity. Think about everyone that you know. Do you expect that everyone can breathe out exactly the same amount of air in one go? If you answered no, you're right. And I'd like you to use these pictures as clues to try to make a list as to what do you think would affect vital capacity. So have a look at the pictures and try to work out what each of them are showing. Okay, how did you do? The first one here, we're going to go left to right. The first one here shows that sex affects vital capacity. Males on average have a higher vital capacity than females, likely because of their body size and their body shape. They've got more space and they've probably got larger lungs as well. Physical fitness. The more fit that somebody is, the higher their vital capacity will be, the more air they will be able to blow out of their lungs at any one time. Also, posture is very important. Of course, if you are always hunched and slouched over, you are squashing up your lungs. They don't have a lot of space to do their job. So if you're sitting up nice and straight, then you are stretching out your abdomen and you are giving your lungs a chance to do their job the best that they can. Chest size affects vital capacity. Obviously, the bigger the size of your chest, it means that your lungs will most likely be larger and you'll have a larger vital capacity. And your age. Between 20 and 35 tends to be the best because by 20 your lungs have fully grown and developed, and after 35 it starts to go downhill a little bit and you lose a bit of lung function. So, did you get all of those? Write them down if you didn't and correct the ones if you need to change anything. Okay, before we actually test our vital capacities, we're just going to find out what we expect them to be. Now, this doesn't mean that you're going to do this calculation and then you're going to test your vital capacity and it's going to be exactly this number. But what this number is going to tell you is roughly, for your age and for your height, what roughly should your vital capacity be? So if you are female, write down the top equation there. If you are male, write down the bottom equation. Pause the video, do that, and then we're going to see how we can use these. Okay, I hope you've got your calculators ready. You can use your computers if you don't have one, or you can use your phone. Now, I'm going to have a go at mine here. So for Miss Moore, I need to know my age and my height. So I'm 30 years old, and my height in centimetres, which is important to get it in centimetres, is 162. So if you're going to have a go at this, and please do, look at the blue box now. We're going to go down the steps. First of all, you have to multiply your age and a different number if you're female, a different number if you're male. If you're female, multiply your age by 0.101. If you are male, multiply your age by 0.112. Do that first, get your first answer and write that down. Step 2, whatever answer you've just got, you have to take that away from your number. So if you are female, you're going to do 21.73, take away your answer. If you're male, you're going to do 27.63, take away your answer. Have a go at that now, and then you should have your second answer. Write that down, have it ready. For step 3, whatever answer you've just got, your second answer, you're going to times that, you're going to multiply that by your height in centimetres. That should give you your final answer, which is your expected vital capacity. If you've done it right, it should be roughly, very roughly, around, mine was 3029.4. Yours will be slightly different because obviously we are different heights and different ages, but it should be, you know, not around 10 or 12, or it shouldn't be huge like 10,000. It should be somewhere probably between 2,000 and 3,500. So check if it's roughly correct and try again if it is not quite there.
Hey, year 8, it's time for you to test your own vital capacity. And in your pack you should have a balloon. We're going to use this for 2 experiments, so be really careful that you don't pop it. First of all, what you want to do is get your balloon and give it a stretch, because what we're going to do is try to make it quite a circular shape. Well, not circular, spherical shape when it blows up. We're getting rid of that oval shape. And to measure your vital capacity, remember what it is the biggest volume of air that you can exhale after doing the biggest, deepest breath that you can. So I'm going to show you how to do this. I'm going to do a really, really deep breath, and just in one breath, I'm going to blow out as much air as I can into the balloon without breathing anything in, and then just hold the end so that we can measure it. So, stretch out my balloon, I'm going to do a big deep breath. Oh, you got to breathe until you really can't do anything else, and then that's your balloon. So, what you have to do, and you might want to get a helper for this part, what I'm going to do is tie up my balloon. If you can't tie your balloon, you can hold it tightly and get a volunteer to help you. If you can't tie your balloon, go and see if you can find someone that can do that. Because now what we're going to do is measure the diameter of this balloon. I would suggest using 2 rulers. I would put a ruler up at the front here. And a ruler just at the top, just so you can just make sure you can see where you're measuring. And you want to just see where your line is hitting. That balloon is at about 17.5 centimetres. So I'm going to write that down. Number 1 was 17.5. Right, we're going to do that 2 more times. And normally we want to find the mean of something, but in this case we just want to find our best result. So we'll do it 2 more times. Okay, so I've done the experiment 3 times. Oh, and it's very tricky to do. You feel very, very out of breath because you're literally using all the breath that you can. I think my best one here was 17.7. So keep watching and we're going to find out how to convert that number into what our vital capacity is.
Okay, after you've got your breath back, bring your best result and come and find out what that means for your lung volume. So reading off the graph here, you need to first go along the bottom, the x-axis, where it says balloon diameter. Now mine, best one, was about 17.8. So I'm going to read up from 17.8 until I see that graph line, and I'm going to read across, and mine looks like it's pretty much spot on, 3,000 cubic centimetres. So find out what yours is and write it down.
Okay, so you've seen us do the balloon test. There's another test that you could do at home if you want to. If you can find the equipment to do this, what you'll need is a sink full of water. We're using this is called a trough, but you can use a sink full of water. And you need a big bottle. Now this one's 5 litres. What you could do is use a 2 litre bottle, so like a big bottle of water or fizzy drink. They tend to come in 2 litre bottles. You might want to have a couple of them available. You might want 2 2-litre bottles. It depends how good your vital capacity is. Because what we're going to do, you need to have your sink with a good level of water in it at the bottom there. And we want to fill this up so that there is no air in it whatsoever. Right to the top. Ooh. Right to the top. Now here's the tricky bit, and this is going to be heavy, so make sure you've got someone to help you and make sure you're doing this safely. You don't want any water to escape while you're putting this bottle in the trough. Mine's already escaping you, right? Don't do what I'm doing. Okay. Ooh. And what you want to do is seal it with your hand, turn it upside down, and only let go when it's underneath the water. So you should have an upside down bottle, totally full of water, with no air in it. And I think we've gotten away with that. There's only like a tiny air bubble, but that's not really going to affect our results. That'll be okay. Now, we've got in here in the department, we've got some tubing. If you don't have any tubing at home, which I don't expect, so you really will, you can use a straw, and you can put your straw underneath your bottle because you're going to be blowing into one end of the straw. But I'm going to use this tubing, and I'm going to very carefully try to make sure that the end of my tube is going in the bottle there. Okay. Now, exactly the same as with the balloon, I'm going to take the biggest breath that I can, and I'm going to exhale as much as I can in one breath into the bottle. And what's going to happen is that the air from my lungs is going to push the water out, and we should get air bubbling here at the top. And with that air at the top, we can then measure down the side what my vital capacity is. We've marked this bottle. We've measured out that this is 1 litre, that's 2 litres, that's 3 litres, that's 4 litres. So if you're going to do this at home, make sure you've set up your bottle beforehand, use a measuring jug and measure how much water goes in. Right, ready. Okay, Don't block the air in the tube because nothing will go through. So make sure that you are not, like I've just done, leaning the bottle onto the tube. Otherwise it's not going to work. Let's try again. Take two. It's all good. It's fine. Ready. Oh, and what we didn't really account for is that now this water's going all over the table, but that's okay. We're going to ignore that for now. Make sure your sink is not too full when you're doing this, as we've just discovered. So in looking at this, I can see that if I put this bottle just upright, my vital capacity is 1, 2, 3, maybe 3.8 litres. Quite pleased with that. I think that's an alright result. And so if you'd like year 8, try that at home. Make sure your sink's not too full, don't make a mess, and good luck.
So now you should have two different numbers. You first calculated your expected vital capacity. So what should your vital capacity approximately be with regards to your age and how tall you are? But now you've tested and you found out what your actual vital capacity is, and we can see what you're working at as a percentage of your expected vital capacity. And it's a nice, simple calculation. What you have to do is divide your actual vital capacity, the one that you just tested and you found out, divided by your expected one, the one that you calculated at the beginning. Then you need to times whatever you get by 100. So first of all, for mine, my expected one was 3029.4. That was based on my age and based on my height. My actual vital capacity was around about 3000. So I do 3000, the smaller number, divided by the bigger number. Well, your actual divided by your expected. 3000 divided by 3029.4. Press equals on your calculator and then times it by 100. And my percentage is 99.03%. So that's really good. It means that my vital capacity is pretty much what it should be, but anything over 80% is normal. That's around about standard. If you get less than that, don't worry at all. But around 80% is roughly where most people will fall, 80% and above. Okay, well done. You've tested your vital capacity. Hopefully you enjoyed doing that and it was fun. And now you could maybe, if you want to, you could test your family. Who would you expect to have the highest vital capacity? And then after testing them, do they really have the highest? So maybe you could make a hypothesis. Who do you think would have the highest? Test it and see if you're right. Now that you've done today's lesson, really well done. Head to Show My Homework for a very quick quiz to see how you've done today.